So, hi everyone. I hope you guys are ready to do some cool art stuff. A big thank you to Maggie for the presentation. As you have heard from her, growing your skills in anything, whether R, Python, whatever, you have to practice. You have to take the initiative to do the learning. So you can learn in so many ways. You can do some online courses, for instance, to learn your art skills. You can practice, for instance, use the hashtag. You can actually follow people like Hadley Wickham, people in the community who are sharing a lot about R on Twitter, on LinkedIn, to get their updates every other day. Like for instance, whenever Hadley Wickham has a new package, for instance, he's going to post it on Twitter. So how will you know if you're not following him? So getting to follow, also reading some blogs online. So like for instance, many companies like Google, Uber, they normally have labs for machine learning and data science. So if you want to learn new things every day, read those blogs every day. There's some data scientists who are really good. They normally have their own personal blogs where they post things, whatever they are doing at their workplace, anything new they are learning. You can read them every other day to at least uplift, upscale yourself. Because if you just come for the meetup, for instance, we learn some cool art things, then you just go home and not do anything. There's no way you're going to grow your skills. So like anything you want to do in your life, you have to practice every other time. Welcome to the session for today. So session is about data wrangling in R. So something about me, as you have heard, I work at Mkopa Solar. I've been there for around 1.5 months. I use R most of the time in my work. And a typical day for me involves SQL, because our data is a database. So if I need to do some analysis, I have to use SQL to extract it. And then I can load it into R or Python for analysis. But most of the time, I'm always using R. So being a data analyst or data scientist, it's not just about coding, writing cool queries, cool scripts. You also need to be able to communicate your results to the audience. For instance, you need to meet with the stakeholder, understand their problem, then you need to formulate, like, how am I going to answer this problem that they're having at the moment? Then how am I going to analyze the data? Am I going to use R or Python? Am I going to use linear regression? Am I going to do graphs? So like all these skills are really important for a data analyst or data scientist. So today we'll just basically talk about coding. Like once you get your data, how do you transform it into a format that can be analyzed very easily? So in the last session, we talked about subsetting in R. So how do you subset a data set? Subsetting like the different data structures. So this workshop assumes that you have a basic idea of the different data structures in R. Like, do you know what a vector is, a list or a data frame? And then, so last time we learned how to subset each of the different R objects. So today we are going to focus basically on like how to do if statements in R and how to do loops in R. So to start us off, I've shared some data and the file I'm going to use today on a Google Drive. There's a link on the board. So if you haven't got the data, please download it right now, because you're going to use it during the session. So once you have your data, you have your script, please put it in a folder, give it a name of your choice. Then within the folder, create a subfolder called data. And in that one, place all the data sets in there. There are 2 Excel files that are in you can get from the link. So put all of them in a data folder. And then you can open the R Markdown, you go through it as we discuss. And then I'll also have some stuff for you guys to try out on your own, and then you can discuss on how to go about them. So, I don't know, how do you normally manage your R workflow? So the best way to manage an R workflow is, once you create a directory where you have your data, a folder for data, maybe a folder for outputs, a folder for whatever thing you're working on, you need to create an R project. What's an R project? So an R project makes it easier for you to manage all the different folders you have in your project. So for instance, for this session, I have an R project. I have called it called Maktaba.R project. So how do you normally create an R project? So let me assume maybe this is your folder, it's called Grace, for instance, and then within it you have data, you have your scripts. So to create an R project for the Grace folder, so you have to go to File, and then New Project. Didn't click. Yeah, New Project. And then depending, because you already have an existing directory, so you have to choose existing directory, and then browse to where the directory is. So in this case, the directory is here. It's called, let me just call it this one. Then open, and then create project. So once I create the project, it's going to open a new studio session with the name of the folder, which is GCC. So if I go back to my GCC folder, I'm going to get a new file called gcc.rproject. So once you're done working on your script, saving everything in the folder, and then you close it. So the next time you want to start working on the same project, you just come and double click, and then it's going to open a new studio session. Then it's very easy to navigate the files within your folder. You don't have to set the working directory or whatever. It's just very easy. Just use relative paths to access your files. So I'm assuming at the moment now you already have the data, you have the scripts. So I think we can start the session. So let me just go back and open my project. And then once I have my project open, it's very easy for me to have a look at the files. If I look at the Files tab, I can see all the files in my project. So if I need to open a specific script, like maybe I want to open this one, for instance, I just click on it, then it opens within my session. So just a recap on what we learned last time. So whenever you install R, it's called the base R. But then if you want to extend R's functionality, you can use some packages that have been developed by some very good people. So the packages are stored in some repository. So the first thing you need to know is like, which package do I need? So like in this case, we are going to use a package called dplyr, another package called par, another one called read excel. So you have to install them first in R using the function install packages, and then in brackets, the package name. So if you don't have these packages installed, you can install them right now. Alternatively, if you don't want to write the code, you can just go to packages and then click install package, then type I want to install dplyr, and then it's going to install for use in this session. But it's always good to use the script because it's easier for you to run it another time. So, I already have my packages installed. I have dplyr, par, and read excel. So dplyr is the de facto package for data management in R. Par provides some very cool functions for looping through files in a fancier way. I'll talk about it later. And then read excel is a package for reading Excel files into R. So once you have these ones installed, make sure you load them into R using the function library. So library, then in brackets, dplyr, par, and read excel. So once we have that, the next step is we are going to use some data in our session. So I've shared with you a data set called Marketing Customer Value Analysis Merged. That is the file, the data collected from some marketing campaigns in a bid to understand how different customers respond to different marketing strategies. So as you can see in line 92, I am importing my data into R. So because it's very easy for me to import because I have the read excel, a function from read excel package. Then I supply the link, like where the path to my file. So my file is contained in data, then stroke marketing value command.xls. So as you can, I don't know whether you guys normally use this. I normally like using this as assignment operator. So I'm creating a new object called bankdf that is going to store my data set. So if I run this, Control Enter. If I look under the Environment tab, I shall be able to see the bank DF dataset I've just loaded. So you can try it out also. Import this dataset into R. And then what is the first thing you need to do once you have your data is to check its structure. Like how many variables do I have, how many observations do I have, and the type of variables that I have. So in my case, there are two functions that you can use. There's a function called str. Most people know that. But then I like this one called glimpse. So glimpse, well, is a fancy one. But as you can see, I have bank DF. Then I have something called the pipe operator. And then I have the function glimpse. So what is a pipe operator? It allows you to structure a sequence of operations and such that whatever is on the left is used as an input in the whatever is on the right. So alternatively, I can just do glimpse in brackets bank DF. But then if I use the pipe operator, I have to specify the dataset name first and then the function later. So if you run this, you should be able to see the output. So the output shows you the number of observations you have, the number of variables, and the variable names. So I have like the customer is a character type. You can see like an example is the customer lifetime value is a double, an integer. Like a date variable is type data type. So this one gives you an idea of the data you're going to work with at the moment. So I hope everyone already has data in R. Who is having a problem probably importing the data can carry a hand, then can have Keegan help you out or anyone else in the team. Okay, I'm assuming everyone is good. Okay, it's nice. Okay, so let's do a recap on what we did last time. I'll just have a very short session on this. So we learned about subsetting data frame columns. So the deployer package has a very nice function called select, where you just have to specify dataset name, then pipe it, and then select, and then define the column you want to select from your dataset. So if I run this first line, it's going to get a new object called location code. There's a data set, and it's going to contain only this column. But then I can also use this function called pool. So pool extracts a column from a data set and saves it as a vector. So the output of these two runs is different. So as you can see, the first one, I have locations, a data set with only one observation. The second one is from the pool, it's a character vector. So if I want to select more than one column, I just need to list them and separate them with a comma. So this output true should also be a data set with only two columns. So if I open this one, I only have the two columns I want to use. So another thing you might want is maybe you want to filter rows. You want to drop some observations you don't want to use it. Maybe for instance, you have some rows with missing data. You don't want to use them in analysis. What do? You drop them using the filter function from deployer. So an example is, I want to get a data set called out that only contains people whose income is more than 0. So if you're filtering using numeric columns, you can use some of these operators called relational operators. So an example is greater than, not equal to. So in this case, I'm using I only want to filter where income, which is a column in a data set, is more than 0. So if you want to filter character columns, I need to use the double equals. So for instance, I only want observations where the class of the vehicle is a sports car. So I need to use the double equals, but then I have to specify the sports car in quotes because it's a string. So what if I want to filter using more than one item? I want to have a car of class 2-door car, another one of class 4-door car. So the easier way of doing it is just specify the data set name, pipe it, and then filter, and then define the column, which is the vehicle class, and then use this in operator, and then specify whatever you want to filter using in a vector. So you have to put them, create a vector using this C statement. So C kind of like puts them together in one object. And then if I run this, I'm only going to have a data set with only, whose vehicle class is only these two types. So if you guys are okay with the recap, I think we can jump into today's session. So today we are going to talk about conditional statements. These are basically something that control the flow of your analysis. That they check if a specific condition that you have specified is true. If it is true, it will evaluate a set of statements. If it's not, it will do something else. So examples of statements that we use for controlling the flow of analysis, like the if statement, and then there is the if-else statement, and there is the which statement. I don't know whether you guys have ever used them before, but we just dive into them. Like for the if statement, it executes a set of statements when a condition is met. For the if-else statement, it does the same. This one, this if-else, that's the same, but then it works on a vector of more than one length. So let me show you some examples. Maybe it will become clearer with examples. So let's begin first with the if statement. So suppose you have an object in R called x is equals to 9, and then you want to check like if x is more than 10, do a square root. If it's not, print something else out. So this is how you specify. So the if, let's specify the if, then in brackets specify the condition of your interest. So in this case, our condition is x more than 10, and then you have to open the braces to specify the statements to be run if the condition is met. So if x is more than 10, give me a square root of x. If it's not, so else take care of like what if it's not met, then it will print like the number is less than 10, no computation. But then take note, this type of if statement, it only works with a vector that has one element only. So what if my x has like two elements? Like let me see what R will tell me if like I have maybe something like 7, I have a vector of 7 and 9. Then I want to apply this if statement. So it's going to give me an error and tell me the condition has a length of more than 1, and only the first one will be used. So the only looked at 7 only, and since 7 is less than 10, then it's going to print out this statement. So let me give you a use case, like where I normally use the if statement. So when I'm installing packages, so most of the time when you're working on a project, you might work with colleagues, a group of, collaboratively. So they might want to get your script and run it. I think it's very annoying if I have someone's script, they're loading packages, but then I don't have them installed within my R. So the script is going to break when I run the script. So what do we do? So the first thing you can do is like you put a list of the packages you need in a vector. So in this case, I need to use tidyverse, glue, all these kind of packages. And then the next thing I want to see is like I want to ask R, check among all the installed packages whether the ones I need to use are installed. So this next statement, what it does is it calls this function called installed packages. This function basically it lists for you all the packages that you have installed in your R. And then the first column of this output is basically a list of packages. So if I run this statement, let me see. So I have this vector called installed. So it lists all the packages that I have. So let me just run it so they can be able to see how many packages I have. They could actually be many. Like all these packages, I've installed them in my R. So what the next statement will be, this one, is going to create a vector of missing packages. So in that case, I'm going to specify, these are the packages I need, and then I'm going to say check. So this statement, what it does is, for each of the packages in this vector, is going to check whether they are present in the installed packages. So if they are not present, that's why I put this exclamation mark, like give me those that are not present in the installed packages. So if I run this, I should be able to get packages that are not. So let me just check if I have. So this package is not in my installed packages. So what the function will do is, as I use the if statement to check if the length of missed packages is more than 0. Because if all these packages are already in my R, then this one is going to be missing. There won't be anything here, so the length will be 0. But so if the length is more than 0, then install the missing packages. So my code will not break. It will just check, okay, you don't have package A, B, and C, let's install it. So this is one of the ways in which you can be able to use the if statement to install packages. Whenever conditions are not met, what will happen? So it is easier for someone to work on a script. So the next statement is the if-else statement. And this is the structure of an if-else statement. So specify the function name, and then specify the condition. What is your condition? And then if the condition is met, the second argument is going to be executed. If it's not, you have to specify what happens if the condition is not met. So this is a very easy one. So the good news is it can be applied on vectors. You can have a vector of length 1,000, it will just work out fine. So this means you can also use this to create new variables in a data frame. So an example would be, suppose I have a vector of numbers, as you can see here, but then I want to replace all the negatives with 0. So what do? The first thing I do is specify my condition. So check where numbers, this is less than 0. And then what do? Replace with 0. If it's not less than 0, what do? Replace with numbers. So if I run this, my outcome should be, like the first 3 elements should be 0 because they are less than 0. The last 3, since they are more than 0, should just remain the same. So any confusion between the two if statements? Silence means good. You have?
Else if. You have to do if, and then execute, and then you can do an else if for the middle before you go to the default state.
So this one? Or which one?
Well, like now you have if x is greater than 10, right?
Mm-hmm.
Then after that you can have an else if before you go to else.
Yes.
So then how can you execute that in the same bracket?
So with this example?
No, okay, this one is just if
and else.
Use the mic.
Okay.
For the camera.
Oh, for the camera, okay. So here you have if, right? If x is greater than 10, right?
Yes.
And then if x is not greater than 10, then it should go to else directly, right?
Yeah, I should print this, yes.
Yes. But now you can have a statement which is between if and else, which is called else if.
Else if, yes.
Yes. So how do you?
You just have to add it here. You can have a list of so many if-else statements. So add else if, maybe x is, I don't know, equal to something. Maybe 10. So you can have as many. Maybe in this case I want to print x.
Yeah, sure. Here, okay. Here it's okay. But now in the other statement, don't.
So in this other one, so when you have multiple,
exactly.
Yeah, okay.
That's what I was wondering.
Yeah, I wanted to give you an exercise to try out. But anyway, we'll discuss it after the exercise. Yes. So one of the ways I can use these if-else statements is to create a new variable. For instance, an example would be, I have a continuous variable. I want to categorize it into 2 groups. So in this case, I have a column called number of open complaints. So the people who had no complaints, they have a 0 number of complaints. The people who had more than 1 or something like that. So I want to create a categorical variable such that if the number of complaints is 0, it should indicate no complaints. If it's not equal to 0, it should indicate at least one complaint. So how do I go about it? I can use base R. Well, I think once you start using dplyr, you'll not use base R anymore. Anyway, but I'm just showing you just in case maybe you feel like you want to use base R. So how do you go about it? So to create a new variable using base R, I have to specify the dataset name, and then the $sign, and then the name of my new variable. And what is my new variable? My new variable is equals to, if else, check if, I have to specify the dataset name, the continuous variable that I want to apply the condition to, number of complaints. So if number of complaints is equal to 0, and then that means complaints category should be equal to no complaints. Else, it should be equal to at least 1 complaint. So let me run this to show you how it looks like. So as you can see, this is the new variable. This is the original one. So the table statement in R, it helps you to generate frequency tables. Basically, when you have continuous variables and you want to see like how many males or females do I have in my data set, you can just call the table statement and then dataset then specify the column you want to analyze. So in this case, as you can see, this is the original continuous variable. People who had 0 complaints are like 7252. This is my new variable that I've just created. As you can see, then people with no complaints is 7252. And then if I want to do the same using dplyr, I have to specify the dataset name I'm using. So something you need to note is when I'm using dplyr and I want to add a column to my dataset, a variable, I have to equate it to the same dataset, because sometimes there are people who want to create new objects every time, like, oh, I want to have maybe bank df2 is equals to bank df all this, but then I want the variable I'm creating to be added to the dataset that I'm working with. So I have to specify the dataset name first. It's equals to pick bank df dataset, and then what do? Mutate. So mutate is a function in dplyr for creating new variables. So once I call mutate, I have to specify what is the name of my new column that I'm adding in my data set. So I'm going to call it complaints category 2. And how is it created? If else, number of complaints is equals to 0, it's going to be no complaints. Otherwise, no complaints. And I think as you have noticed, whenever you are using base R to extract a column from a data set, you have to use a $sign. But if I'm using dplyr, I don't have to. That's a good thing. Like $signs every time can be exhausting. So with dplyr, I don't have to specify the $sign. Just say I have to specify the variable name I want to analyze. So if I run this, I should get the same output that I had before. So I can see people with no complaints, then some no complaints. No complaints. So I want us to try some exercise before you talk about the which statement. So for the exercise, I'm assuming you already have the bank dataset in your session. So I want us to create a new variable. You want to call it income category using the following protocol. So if the income is 0, call it no income. If it's between 1 and 50K, call it 1 to 50K. And then if it's more than that, then call it this. So use the if-else statement, but then use a nested if-else statement. So I want you to try your imagination how it's going to work out. So since you already have the script, you can always check like how I implemented the previous if-else. But then what if it's nested, like whatever this guy was asking, how do you go about it? So let's take at least 5 to 10 minutes to try it out. If you have challenges, raise your hand. I'll come over and help you. Keegan can help you out. Let's use deployer. So the first thing I need to specify is my data set, which is bank df, and it's going to be equals to bank df, and then I have to pipe. And then using the mutate statement, I create my new variable. So let's call it income category. Category, which is equals to. So I have to specify the first if else. So my first if else is it checks is income equal to 0. If it is yes, and then specify no income. So like basically if I'm only having one condition, then I will specify like what if it's not met. Maybe I'll say something else. But in this case, because it's nested, where you're supposed to say no. And let me show you the structure for the if else. It only has two conditions, 3 arguments. So you have the condition, then we have yes, then we have no. So in this case, I specified income is equals to 0. If it's equal, maybe say yes is no income. So for the no, I don't specify the no in this case. I put another if else statement. So you can actually have like so many nested statements. If else income, but then there's a fancy function in R called between. Things from the deployer package. If you want to filter numeric variables, and if you specify the upper and lower bounds, they are basically inclusive. So I have to use if income is between 1, that's the lower bound, and 50,000. That's 50K, and then we have to put 1 to 50,000. 50,000. Else I have to put, okay, let me see if I'm missing out something. Yes. Else I have to put greater than 50,000. Make sure you have closed all. So the danger with doing this is sometimes the income column can have missing values. So if I just say like else replace 50K, so even we have missing income, you might actually put them as more than 50,000. But now for the sake of this one, let's just stop here. Now there's an error. I don't know where it's coming from. So if once I run this, I can do a table statement to check the distribution of my new variable to see how many people do not have income in my data set, how many have income. Yep, I'm good. So don't worry. I think with time, you just get used to this stuff. Practice makes perfect. So if there are no questions about the nested if else, I'll share this. I'll push to my GitHub repository, then you can check it out. So the last statement is the which statement. Well, I can't recall how many times I've used it. Very few times, but it's just good if you know them. So at some point, if you want to use it, you can use it. So the which statement, it takes in, it can work on a vector of more than one element. So an example that I want to show you with is, so the nini is very easy, the syntax, which, and then in brackets the condition. So it returns the raw number which meets the condition. So for instance, I have a vector of weights, but then I just want to know the positions of within the vector where the weight is more than 13. So let me just run this. So I look at the output, so position 3, 4, and 5, which is 14, 15, and 17, the weight is more than 5. So mostly the outcome of a which statement is used in subsetting vectors. So in this case, maybe someone asked me, okay, give me a list of weights that are more than 13. What do I do? So I have to specify the vector's name, and then to subset a vector, I need to use the block brackets. So the outcome of this one, as I said, is going to give you positions. Position of where the weight is more than 13. So that means it's going to take the vector and pick all the elements in positions 3, 4, and 5 and give me. So if I run this, I need to be able to get 14, 15, and 17. There exists some variants of the which statement. So maybe I want to get the maximum weight or the minimum. There's a function called which.max, then which.minimum. So any questions on how to use the which statement? Okay, so let me add a missing value. So missing values in R are denoted with an NA. Yeah. So running this, running this, so weight should have a missing at the end. So it has an NA, it's a missing value. So I want to get missing values. So to get a missing value, there's a function called is.na. Like, is it missing? So instead of 13 here, I'll just wrap the inside the function is.na. So it will give me the position of the missing, which is position 8. Then I can just copy this inside and here to replace it, so it can give me the missing value. But of course, you don't really want to see the NA. So I think as you continue playing around with R, you stumble upon so many functions that really help you in your work. Okay, so exercise is done, the statements are done. Maybe we can talk about loops now. We have different types of loops. We have the for loop, where if you have repetitive tasks, because like an example would be, you have a bunch of CSVs you want to read, like 100 CSVs, an example. So how do we import them into R? It will be like CSV1, read.csv, the path, CSV2. So you're going to have like how many lines of code? 100. But then a loop will come in handy when you have such kind of repetitive tasks. You just write like 2 lines of code and you'll be done with the analysis. So, and the one he's talking about is the while loop. I think I rarely use the while loop in my work. So, which mostly is going to execute something when a condition is met. I think for this session, let's talk about the for loop. So, I've already given you an example on when you can use a for loop. When you have repetitive tasks to work on, or maybe you have a function that does something in R, and then you want to apply the function to so many inputs, then you can be able to use a for loop to do that. So like, what is the structure of a for loop? So here I have the structure of a for loop. So you just begin with for, then in brackets, you have to specify it's called the index or the placeholder. And then so in this case, my placeholder or the counter is called I. You can give it any J, K, whatever you want to give it. And then the next step is in. And then you specify the start and the stop. Where should the loop start? Where should it end? And then now you have to open the braces and specify the statement that should be run for each of the runs. So that means in my case, I have like for I in 1 to 4. So it's going to, like the first time when I is 1, it's going to execute the statement and give me an output. So let me show you an example and maybe will help us understand a little bit more. So in this case, I want to write a for loop that should print all from the start to the stop. So in this case, like I have for I 1 to 9. So for each run, it should print out the counter at that point in time. So running this will just print 1 to 9. But then you might have something more complex that you want to use a loop for. So let's go through the steps on how to use a for loop for any task that you want to do. So an example is, suppose we want to import data from an Excel workbook that has so many sheets. It is so stressing to have to say read Excel, data set name, the sheet name is called, I don't know, maybe data 1. Read Excel, data 2, whatever. It's so exhausting. So what do? Go for a loop. So what is the first thing you need to do? The first step is like identify the function you want to use. So in this case, I want to use a package called read Excel, and within it has a function read_Excel for importing Excel functions. So the second step is I need to create a vector with the names of the worksheets. This is what I'm going to loop over. So there's a data set called several. I think I hope you have this data set in your data directory. You can import it. So it has so many Excel sheets, I know around 4 or 5, I'm not sure. So like how do I create a vector of sheets in my workbook? So the read Excel package, it has a nice function called Excel sheets. So what you only do is supply the name of the workbook. So in my case, my workbook is called several data sets. So running this, the function will just go pick the Excel file and then look at the different worksheets that I have. I think something is wrong. Okay. Yes. So my data sheets are check weight, Star Wars. So if I go back to my directory and open this data set, I should be able to see all the worksheets. So you can see I have check weight, but then you could be having as many, like so many worksheets. So once I list the worksheets, then the next step is, first it's good to test where the function will work in the first place with one data set. So how do you test it? So use the read Excel package function, specify the path to the workbook, and then specify the sheet name. So in this case, I want to import data for a sheet called Star Wars. So if you go back to Excel sheet, there's a sheet called Star Wars. So if this works on one sheet, then it should work for the other worksheets also. So as you can see, I have my data set here, the Star Wars data set with all the variables. Okay, so I'm done. I have the function defined. I have the vector of sheets I want to loop over. And then I have tested my function, it's working. Now then I can go ahead and create a for loop. So what's the first thing? So I need to create an empty list that will be used to store the data I'll be importing. So how do you create a list in R? Give it a name and then call the function list, then in brackets, list. So this data sets list is going to store all my data that I'm going to import. So the next step is write the for loop. So there are different ways of creating a for loop. You could use a numeric index. So a numeric index will just basically use numbers. So the first step is data set index, which is my list for storing my data sets. And then this is the structure of my for loop. So for I in, start at the first counter, which is 1. Then where should I stop? I should stop at the length of the worksheets. So this function, it gives me the number of worksheets that I have. So like I shouldn't have 4 worksheets, but then I'm looping from 1 to 10. Doesn't make sense. So this is an easier way for you to identify like how many items do I want to loop over. So in this case, I have 5 worksheets. So that's why I'm specifying from 1 to the length of the number of worksheets. And then what next? I need to import the data. And then the thing is like, as I continue, let me just print I here so that you can see as it runs. Oh, sorry. Print I. So the loop is going to start at I is equals to 1, execute, then go to I is equals to 2 up until 5. So, but then I want to be able to save the different data sets into a list. So that's why you can see the list I've gotten here, which is an empty list. So I'm going to be filling it up with the different worksheet data. But then how do you fill up a list? You need to use the double, are they called braces? Block brackets, double block brackets. So for each run, that if S1 is going to fill the data set. So what do I go about it? So data set index, my list, specify the index, and then say is equals to read the data set, but then the sheet is data sheets, then block bracket I. So if an example like if maybe I is equals to 1, is at counter 1, if I run this one only, it's going to extract the first element of that vector. Oh my. Let me run these ones first. Data sheets. So I is 1. Okay, that's weird. Oh, I didn't run this. Oh yes, I have to run this first. And then, so it should give me check weight. Like that is the first element in my vector. So running this, so let's run this. I can get rid of this one, don't need it. Control, enter. So if I look at my output, it's going to print the index at every point. So my output is already here. As you can see, it's a list of 5. So opening it show me like a list, like the first index contains a data set with 4 variables and 578 rows. Then I can look at the different columns. I can look at true, that's my second sheet. So suppose I want to extract data for, I don't know, the check weight data set. So if I look at my data sheets, check weight is the first sheet. So how do I extract it then? I need to use assign it a name. Check weight is equals to specify the list and then the position of the data I want to extract. So since check weight is the first one, if I run this, it should give me data for the first sheet. So chicken weight contains all this information. So as you can see, if you're using the numeric index to loop over the positions of the elements in your list, you are going to extract them using a numeric index. Then what if I want to use a character index? So for a character index, it basically loops through. I don't have to specify the start and the stop. I just need to specify the counter, which is the placeholder, and then I specify a vector with my sheet names. So that means every time it's going to pick, so the sheet, let me print it so you can see how it works. So it's going to pick the first sheet, second up to the 5th sheet. So let's run this and see how the output looks like. So as you can see, it's going to, so the sheet placeholder is going to pick every sheet name in this vector. So the first one is check weight, star up to air quality. And then if I look at my output, it's going to be different from the first one. I hope it's this one. No. As you can see, the elements of my list now have names. Check weight, but previously I didn't have names. I only had indices. So you can choose like which one you want to use. Do you want to use indices? But I think the name one is easier for you to be able to identify which one you want to pick out. So if I want to extract data for the check weight, I'll just call the list, block brackets, and then check weight. Specify the name of the element in the list. Then it should give me the check weight data set. So I think the most important thing is you need to know when should I use a for loop. So you only use it when you have something repetitive. So in this case, what is repetitive here? We have 3 columns. So for each of the columns, we are doing the mean, we are doing the median, standard deviation. Then you go to the second column and do the same thing. Third column, do the same thing. So how do you make sure that you can be able to use a loop in this case? So the first step is create a vector that you are going to loop over. So in this case, I want to loop over the 3 variables. So what my first step is, let me create a vector, call it calls. And then let me just copy this one. and then I have to put them in quotes because they are not numbers. So you can only have a numeric vector or a character vector. So if you have anything that has letters in them, that is a character vector you have to create. So I have a list of columns to loop over. So what is the next step? So where do I want to save my output? And I think from the instructions is save them in a list. So I need to create a list, maybe call it output, maybe list, an empty list that is going to hold the outputs. Okay. Now the next step is to create a loop. So I'm going to be looping through the calls vector. So for I, so let's use we can use the character vector, character index, or the numeric one. So maybe let's use the numeric one. For I in 1, 2, the length of calls. So what is the first step? So the first step is to extract the data, the column from the data set using the pull function. So I can just give it any name, like maybe call it maybe data is equals to, because this is a temporary object that is going to be replaced every time the loop runs. So data is equals to, take the bank data set and then pull calls. But then calls is a vector, but I only want one element each time. So to subset the elements, I used to use the block brackets and then say specify I, which is a placeholder. So now I already have my data. Actually, the best thing would be, let's test it first on just one. Then I can now copy the code into the loop. Okay. So I have data is equals to take bank dataset, bank, and then pull out the first element of calls, which is, so if, let me run this one first, control enter. So if I run this one only, I want to extract the first name, it should give me income, because that's the first element in my list. So running this control, it will create a vector called data that contains 9134 elements, which are income values. So what the next step is, I want to calculate the mean. How do I go about it? I can create an object called means, or whatever you want to call it, then call it means. So mean function is just called mean, and then supply the data. And then the next thing I want to do, I want to calculate the median, call it med. It's the same case, median function, and then supply the extracted data. So the next one is, I want to send a deviation, maybe call it SDS, and then SD data. And then the next thing is, I want to put all these objects into one vector. Let me call it maybe temp is equals to C. Then I put means, med, and then SDS. So when you're creating a vector, is always, anyway, you can create a named vector. So a named vector means that the element of the vector I'm going to have names. So an example would be, if I have a vector called age, and it has values 1, 2. So running this will create a vector that is not named, because I just have 1 and 2. But then a named vector, I'm going to give a name to each element of my vector. So in this case, maybe let me call this one 1. So a name should have a quotes, and then this is my 2. So that it's easier for someone to read when they're reading this one. So as you can see, I have 1, then 2. So in this case, I'm going to do the same in this case. I want to create a vector that is named, maybe let me call it mean is equals that, and then med is median, and then SD in quotes. So running this, so if I call temp, the output should look like the mean of income is this, median is this, the standard deviation. So once I've tested the body of statements that they are working on one of the columns, then I just copy this and paste it here. So wherever there is always remember to make sure that your code is intended. So the only thing I need to replace is where there is 1, I need to put I, because it's going to be changing every time. And then now I have my output. The next thing is I want to put that output in a list, because every time if I run, it will be replacing the temp. So I'm going having it, say when I is 1, I'll have the output for income. When it's 2, for the claim amount. But then I want to be able to see all my output. That's why now you have to put a list. So I've already defined a list which is empty. So I want to keep filling it every time. So I use the double block brackets. I is equals to temp. So it is run. So let me see. I just open the list. Let me see what I'll see. So it's going to give me a list with 3 elements. So the first one will be the output for the income, second for the claim amount. The last one is going for the customer lifetime value. So I is a counter or a placeholder. Because if I have to loop through a list of things, so I is going to take different values at different times when I'm looping. So the first time I'm looping is going to take 1, because I'm looping from 1 to the length of calls. So length of calls, length of this is 3. So its length is going to be 3. So it's going to be 1 to 3. So okay, let me print so that maybe it's much clearer. So I is just a placeholder, because it's going to be changing every time. So when the placeholder, the counter is at 1, I is going to be equals to 1. If it gets to the second one, it's going to be 2, then 3. Because to prevent you from having to run this, like duplicate this code 3 times for this. So now you're using a loop. So I is just taking the position of the counter every time. So if I rerun this, it should print for me the value of I at each run. So I think, as I mentioned before, this percentage is called the pipe operator. It helps you to structure a sequence of operations. Because basically I could just call this function, like for instance, I can just say pull, then the dataset name, the dataset name, which is bank, then I say I want income. But then I could be wanting to do a pull and then maybe do maybe a mean or something else. I could just keep piping them. But then to prevent you from having to specify each operation separately, then that's why you're using we are using the pipe operator, which takes whatever I've specified on the left as an input in the whatever is on the right. That's why you're using the pull. Under the pull function, it extracts a specific column from a data set and saves it as a vector. You can also use the select statement. I can also use select, but the select statement is going to save the output as a data frame. But I don't want that. I want a vector. That's why I'm using the pull. And the pull, it only pulls one column at a time. It can't pull several at once. So this statement is just taking the bank data set and then pulling the columns which are here, which are going to be different every time.
Okay, so you put that percentage greater than percentage just because we have from I, just because we have that I in 1, or what exactly? Because that rotation or what?
This one is just alternatively, I could do this, by the way. I can just replace, do you have any questions about this one? The one, the pull function that I'm using here. So, if you want to check, understand like a function more in R, you can always put a question mark before it and then pull. So if I run this, it should open the help page and explain to me what pull is. So pull is pull out a single variable. So if I look at the documentation, I have to specify the function pull, my data, which in this case is bank DF dataset, and then the variable name, which is income. So I could either use this to extract the income. So let me just run this one. It's going to be a very big output, but let's just run it. So it's going to extract income from the dataset. So the outcome is going to be really long because you have like around 9,000 observations. So alternatively, instead of writing like this, I could say take bank dataset and then pipe it, and then the pull function, and then just specify the income column. So in this case, the pipe operator is going to tell pull that take whatever is on the left and put it as the first argument here. So whether I use this one or this one, they both work. So you can just replace here with this one and it will still work. So the calls one just be picking the elements at the different indices over time. So don't worry, these things like it require a lot of practice for you to kind of master them over time. So I also shared the file from the previous event, which explains the select statements in more detail for you to go through them. Okay, so the last session, maybe you can take a shorter time, but I don't expect you guys to understand like all this today. You'll go and have a look at it because there are just so many apply family of functions. So here I'm just kind of letting you know that they exist. Go and try them out because there are many. So the apply family of functions, they're kind of more fancier loops. I call them like fancy loops. Instead of using the 4i, you just use either of the apply functions depending on the use case. So the apply family of functions, there are several. We have the apply, we have the lapply, we have the supply, apply. There are so many. But anyway, I'll just say like most of the time, I'm always using lapply and apply. So let me just talk about those two for today. But then when you go, I don't know, back home, you can try out the other ones to see all the differences. So what is the apply? So apply is the kind of the parent or the godfather of the apply family of functions, and the structure of how to use the apply function is the first argument is x. So x can be a data set. X could be any object in R data set, or you could have a vector. And the second argument is the margin. No, I think you can't use a vector, data set only. So X should be a data set. So the margin is tells the apply function, apply this function fun, either row-wise. So row-wise is normally the margin is equals to 1. And then column-wise, the margin is equals to 2. So an example would be, I want us to calculate the means of all the columns of the empty cars data set. Now something good about R is R contains some inbuilt data sets that you can use to play around with. So like empty cars, it comes with R installed. So if I run this function called data, R will give me a list of all the data sets I can use with their descriptions. So if you are learning something, for instance, you want some data to play around with, you can just come and say, okay, maybe I want to work on maybe criminals data, for instance. So in that case, just come and call the function data, and then in brackets call crimtab. So in our case, we want to use the empty cars data set. I don't know if I can see it here. Empty cars, which is the contains information about the motor vehicles, their mileage, their weight, their height, is it a foreign car or not, whatever. So let's just, so to call it into R, I have to say data, then empty cars. So it's going to load it. in memory, but then I can't see it directly unless I start using it. So as you can see, it has this promise that like it's already called it, but then it can't show it because you need to start using it first. So I want to calculate, maybe let me just open it. It will be easier for you to, if I do the structure of empty cars, it contains the 2 observations and 11 variables. This is, I think, the mileage, I'm not sure about this one, HP ratio, weight, gear something. I can't explain all the details, but then you can check about it later. So all these columns, they are numeric columns. So the task at hand is use the apply function and then calculate the mean of all these columns. Because like if you want to do it one by one, it will be maybe mean of MPG, mean of CYL, mean of mean, which is, so I don't know, it's not efficient. So to efficiently do this, I just call the apply function. I supply data set, it's called empty cars, and then the margin is equals to 2. It means work on the columns. On the columns, then calculate the function called mean. Okay, let me just get rid of this and then run. Sorry, I should not have this. So it's going to give me the mean of MPG, whatever, CIL. I can have median, I can have SD, I can have sum, I can have whatever I want, or I can define my own function and then supply it here. So as you can see, with just one line of code, I can accomplish so much. So maybe let's try out something. Because of time, I think we'll just discuss it together. So I want us to use the apply function to calculate the row sum. The row sums of the sum total of each row of the empty cast data set. So as I had mentioned, the margin for the row functions is 1. But then, so I can just copy this. Because I want to calculate the total, I have to replace the function with sum. And then I have to change the margin to 1 because it's row-wise. So it's going to give me a vector of length 32, which is the length of our data set. It's going to add up all the columns. So, but then for this vector, I want to add it back to the data set. So how do you create a new variable using base R, for instance? So I have to say empty cars. My variable name is called maybe totals, and it's equal to this. So running this, and then if I open empty cars, I should have a column that just sums up all this. So if you add this one manually, you should be able to get totals. So any questions on the apply function? You can try at home later. And then another one is the apply function. So the apply function takes in input as either a vector or a list. So most of the time I use it when I have a function already created that has one argument, and then I want to call the function on so many elements of a vector. For instance, I have an example. Oh yeah, so let's try using this one. So for instance, instead of using the for loop you're using before, I already have a vector with the sheet names, and then my function I want to apply is import data. I don't know whether you guys have, I think we'll have a session on how to get functions in R, maybe in a future session. Let me just give you a simple introduction to functions. So a function is an R object that takes in an input, gives you an output. Then it's like you're cooking food, for instance, yes. So in this case, a recipe is your function. The inputs may be, I don't know, tomatoes, onions, whatever. Then you do something, then the output is maybe ugali, whatever, for instance. So a function is just a list of statements put together that takes in an input and gives you an output. So let me give you an example of a simple function. So I want to have a function that will take two numbers and add them up. So the first thing I need to do is to create the function name. So maybe call it adding. Give it any name you want, and then call the function. Then specify my inputs. So the input is two values, a and b. I can call it x and y if I want, x and y. And then I want it to add x and y and give me the sum of the two. So I can create a temporary object here called tmp, then say x plus y. And then a function always returns something, the output. So return tmp. So running this is going to add it to my list of outputs in the environment. So functions, I only have one function that has two inputs. So to call a function, I just need to type the name of the function, put brackets, then specify x. So I can say maybe I want to add 4 and 5. So running this will give me 9. I can change it and put 10, whatever I want to do. Oh, sorry. 4 and 10. But then the thing is, a function, I need to specify all the outputs. So if I just specify x or one of them and then run, it shouldn't. It can't run. It will give me like you have to specify y. But then if I don't want to specify y, I can put a default value to y. Like if I say y is equals to 10, so this one, if I run this, it will run because already y has a default value. But then I'm free to change y at any point. I can say I want y to be 7 this time right down. So it will going to overwrite the 10 and use the one I've just supplied. So that's basically how functions work. They make work easier instead of having to do things over and over. Like you want to add around 1,000 numbers. You can't just be typing them every time. But then a function will make it much easier for you. So in this case, I'm creating a function that will take in the name of a worksheet from a data set and then import the data. So I'm creating an object called data. So reading the data, and then the sheet name is called x, which is the input to my function. So once I create this one, it's going to be added here. It only has one input called x. So every time I want to call the function, I have to supply the x. And the x has to exist in my worksheet if I'm importing data. So in this case, I use the apply function. It only has two arguments. So x could either be a list or a vector. So I already have this vector. We had it before. Let me just, so the name of the sheet names. And then what function do I want to apply to the sheets? So I want to supply the function called import data. So running this one to create the apply list. So that's how I called it. So opening it, it will show me how I imported all the data I wanted to import. So if I just expand this, I can see my data set. Expand this one, my data set, expand it. So that's basically like the points in which I want to apply, to use apply. When I want to call a function and I have so many arguments in a vector. So there's another variation of the apply function. So there's a guy, I think probably he loves cats, because he calls a function called par. So if you want to learn about a function, always search for, like for instance, par cheat sheet. It will show you all the functions within par and how they are applied. Or you can look at the documentation of the function from the CRAN website. So CRAN is a repository for all the R packages. So if you want to learn about any package, you can always look for, say type Google, just ask Google par CRAN PDF. It's going to give you a PDF with all the functions explaining how they are applied. So in this case, like par has so many functions, like so many. So I only chose the ones that you want to apply in this section. So par has functions called map. So the map functions, they replace the apply family of functions. So I use sometimes par because it's much more, it looks fancier. So if someone looks at your code, they think you're an expert. So instead of using apply, I can come and use the map. So there's the map is only applied when your function only has one argument. There's the map true when your function has like 2 arguments. And there's the p map when you have like many arguments to your functions. So in this case, our import data function only has 1 argument, so I can use map. And then the structure of map is, I just call the function map, and then I supply my arguments. It only has 2x and yx. So x now is the vector that I want to loop over, and then f is now my function, which is import data. So it should run so well. If I don't want to use this, I can also use the pipe operator. If you want to look a little bit more fancier, that is. So these two should give me the same output. So running this should give me, there is map list 1, and then there is map list 2. So whichever method you want to use, but I think maybe for starters, maybe start using this one, then over time you can replace it with this one. Because as you can see, the pipe operator, I specify what I want to loop over, and then I pipe, and then I call map, then I ask map, like pick whatever specified before and use that input in my map function. So as you can see, then you have to put this tilde before, but don't worry about it right now. With time, just get used to it. So as you can see, I have like map to or p map if you have a function that has more than 1 argument. So any questions? I know there's a lot of content today on apply family of functions. There is the map, all these kind of things are confusing, but then please just go and practice them, try them out and see whether you can actually get a glimpse of them. So with the time you'll have your own favorites, like, oh, I think I don't like apply, I use using the map, and map has so many other functions you can try out to use. So I have a exercise which I think maybe you can try at home, but I will add the solution here and then upload to my GitHub. You can just search F Wanjala, be able to get my profile, and then you can get the output. So just to close this out, thank you so much, guys. I hope you have enjoyed the whole session, and I hope you have learned something. This is just the first step. Like attending meetups, I don't know, opens your scope, opens your mind. You get to meet people, learn from them, learn new things that are happening out in the world. Because if you just over the weekends or in your house all the time, maybe watching a movie or even doing R, but then sometimes there are things that you may not learn on your own. So meeting people helps you learn a little bit more. And then practice makes perfect. Practice, 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 practice. Another way you can learn is, as I had mentioned, like the ones that Maggie had talked about, the Tidy Tuesday. Like if you have make sure you're on Twitter, have a Twitter account, and then follow the right people. Maybe you can begin with Hadley Wickham, because he's, when people mention R, they think about him all the time. And then there are some other people that you can follow that maybe are doing very good in R, sharing stuff about R. There are some handles, like we have the R Weekly, we have even Zindi Kenya, we have Africa R, we have Our Ladies, like just so many R groups that you can join on Twitter, and then daily they post stuff about R. So like for instance, like Hadley just released a package the other day, it's called Multiplier. So like if you're not following him, you won't really know that there are things happening in this world. So follow the right people, check your Twitter, tweet stuff about R, ask people questions, and you'll be able to learn a lot. Then reading blogs is very important. Google has very nice blog. You can always be reading it every other time. We have data scientists who have their own personal blogs. You can read the blogs. They always post something very helpful for you to learn stuff. You can do online courses like Coursera. Well, some of them I have to pay for them, but some, I know DataQuest has a free R course that you can start with. Just learn the basics, and then once you learn, practice makes perfect. And as you can see from the Tidy Tuesday one, they are always posting challenges every week. So you can, once you've learned something about R, go there, pick the data set, try it out. You can try using data sets from Zindi website. You can use Kaggle. So the two websites they basically post, call them hackathons or problems for people to solve. So check the data, try it out. You can decide to publish it on RPubs or GitHub pages. or a Medium blog post if you want. So being in a community is a good thing. You get to learn a lot. Share whatever you have learned with people. People can give you comments, like if maybe you post, your code is giving you an error, for instance. Maybe you say, okay, I ran this not working out, maybe tag like Africa R, for instance. Then someone who's can come and help you solve the problem that you're going through. And then I think just that, I've attached some resources that I used to the whole process. And then there are some books that Hadley keeps writing. They're really helpful. There is one called Advanced R. It's really a nice book. So if you have time, Google it, go through a book, learn as much as you can. And then you can also offer to train, because that's the only way you're going to learn, another way of learning. Like for instance, when I was preparing this presentation, I had to Google some of the stuff. And while Googling, I have been using Deployer for like over 2 years. But then I came upon some functions I've never used before. So like training helps you learn a little bit more. So if you feel like you want to train something on R, anything on R, you can talk to Keegan or Shelmith or Alfred, like, oh, I want to train something on R, can you, I don't know, organize a meetup or something, then they'll post it on their, people will come over, then train them, then while training them, you learn, you meet people and, I don't know, enjoy yourself. So, thank you so much for listening. I hope you have learned so much. I'll post this on my GitHub, check it out, try out things. If you have questions, you can always reach out. I can even put my email here or ask on the, I think AI Kenya, they have, I don't know, is it a Slack? Yeah, it's called Discord. Maybe you can share about it, where people normally meet and discuss about data science, machine learning, R, whatever you want to discuss about. Then just learn as much as you can. So thank you so much. You have a nice weekend.